I'll try to run through this a little bit quicker because I've done question 8 quite in detail. So if you haven't watched that and you want to get more in-depth answers from, for this question, go back and watch the question 8 one. But let's begin. The amount of water V in a pool is directly proportional. So we're using direct proportion to the depth of water D. So we're using those two values. When filled to a depth of 1.25 meters, the pool contains 73 kiloliters of water. So that's the ratio we can use. First of all, find an equation connecting the variables. Okay, so first begin by writing your variables. I'll write it over here. V is amount of water in kiloliters, was it? D is depth in meters. So just writing everything down I can. Now, looking at this, have a think about, what depends on what. Normally, in the question, if you're really, really struggling, because, the water level also, the amount of water is dependent on the depth, and depth is kind of dependent on the amount of water, I would have a look at it and look at the lowercase, uppercase. So V is in uppercase, meaning, it kind of looks like the V should be at the beginning. So we don't know the proportionality constant, so I'll leave it as M, but you know that D would be over here. I mean, it could also have a plus C, a little, if it's off origin, but we know that it's direct proportional, so it's most likely not going to have that little section. So we just need to basically figure out this proportionality constant. Alright, also known as gradient. There's different words, so be used to it. Okay, let's begin. So, for this in particular case, let me just draw a table of values to make my life a little bit easier to find that M value. Now, in the previous example, in question 8, I drew a graph. Honestly, you don't have to. I'll show you a simple formula you can use as well. So start with D and V, so depth of water, when it's 0, you will probably have 0 volume, right? If you have, actually let me just go double check the answer for equation before we move on. Oh, sorry, actually, yep, that's what I was trying to find, my bad. I just wanted to see that the V was the correct, and it was correct. I just wanted to double check my theory. Okay, so start with 0, and obviously it would be 0 because there's no water. Let's start with the next amount of depth, which is 1.25, and then that will be 73 kiloliters of water. Now if I add another 1.25 liters, I will get 2.5 meters, and then if I add another 73 kiloliters of water, I'll get, if I just double it, that'll be like something like 146. So I'm going to stop there. I'm going to show you how to use just the slope equation, slope function, which is the M, which is rise over run, to use this without having to draw a graph. All you have to do is something called, y2 take y1, x2 take x1. Now, if you don't understand this, you might have to go watch some videos on coordinate geometry. You just Google how to solve slope, okay? I'm not going to explain that here because I'm just going to assume you know. Basically, all you need to do is label these coordinates. So this one, in this case, we're not using x and y, but thinking x is independent, y is dependent. This will be our x's, x1, x2. This one will be our y's, y1, y2. So all I have to do is sub those values in. So I'm going to use the same colour, so that's easier for you. y2 is 73, y1 is 0, x2 is 1.25, take 0, so that's just 73 divided by 1.25. Just chuck that in the calculator. I get 58.5. So this is our M value. Okay, just a reminder. So I can sub it all the way back here, and then my equation now becomes V equals 58.4 D. That is my final equation. I'm pretty sure that was what the answer is. I'm not going to go back and check because I'm pretty sure happy with it. Alright, let's do B. Find the depth of the water if the pool contains 40 kiloliters. So again, we want to figure out pool contains 40 kiloliters. Alright, so in order to do that, you need to figure out, how much depth would be if pool is 1 kiloliters, and then times it by 40. So let's look at this ratio. Well, we didn't actually write the ratio, did we? Let's write it down quickly. I'll write it over here. So basically 1.25 meters equal to 73 kiloliters. That's kind of the ratio we're working with. So in order to figure out, pool, this one, what's going on? Pool of 1 kiloliters, I need to figure out the depth of that one. Okay, so I need to figure out, I've got 1.25 meters, and then I just basically need to figure out, if I divide by 73 kiloliters, it'll give me how much would be 1 kiloliter. So if I just chuck that in the calculator, that's a very, very long decimal, approximately 0.17 recurring. I should write 6 recurring. So I'm just going to leave it as a fraction, and we can just times that by 40. So I'm just going to go 1.25 divided by 73 times by 40, which will obviously probably get us another approximate answer. So hopefully you're all following, but it's really just you just got to follow the thought process. I know sometimes that having a decimal on fraction doesn't make sense and etc., but just got to follow the process, because at the end, all the numbers end up being the same. So it becomes 0.6 recurring, but approximately 0.7. So that is the depth of the water. So you give it a unit, meters. Basically when it is 40 kiloliters. So let's have a look at the answers to double check that that is right. So 0.685 meters, which is approximately the same. We've got about 0.6 recurring, which is, if you round it up, 0.67. Okay, let's do the next one. Last one. How much water is needed to fill the pool to a 1.5 meters depth? So again, in order to do this, I would figure out depth of, so we need to figure out 1.8 meters. In order to do this, I would figure out depth of 1 meters and then times it by 1.8 to get that 1.8. Okay, so using this little ratio again, the ratio that we're always working with, let's begin. So, to figure out 1 meters, all I have to do is 73 divided by 1.25. That will give us, it's basically the opposite of this ratio we have already done. Let's see if that gives me a nice number. It probably won't. Oh, surprisingly does. 58.4 for this one. Okay, so now I times 1.8 to it. I get 105.12. Let's write units, so kiloliters of water. Right. So ideally with these type of questions, because the question is asking you in words, you should answer in words. Alright, so once you got these final answers over here, so this one was your answer for C, this one was your answer for B, you would basically conclude, say for B, depth of the water is 0.7, or round it up to 1 meters if the pool contains 40 kiloliters. For C, you would write the 105.12 kiloliters of water is needed to fill the pool to a depth of 1.8 meters. Blah, blah, blah. Let me just quickly check the answer. Remember, checking answer is the key part of the answers. That is correct. Got my correct units, and you are done. So hopefully you can write all of that down. Try it again another time, and yeah.